All right. Good morning, good evening, good afternoon. I don't know what time it is that you're watching, but today's section is 2.8 Homogenous Mixtures, and it's a continuation from yesterday's assignment or yesterday's video on mixtures. I know I have not uploaded. For those of you who are working on your own, I should be uploading it today when I do this one, okay? So right now I'm working with my fourth period class, and I am looking for a volunteer for anybody who wants to read this paragraph, okay? Any volunteers? I'm looking at, I don't know, Catherine, Yalexia's, I would ask Alexia, but she's not here today. Oh no, that's another class. Or Regina, Merari, Manuel. Can you do some reading for me and give you some extra points or something? Or Norberto? Help me out, guys. I don't want to be doing all the reading every single day. Volunteers? Anybody? Maybe I shouldn't have told you we were recording. All right. Armando, anybody? Come on. Somebody help me. Juan Soto, can you read this paragraph real quick? That's the only thing I'm going to ask you to do. No? Miguel, can you read for me? Irene. Thank you, Manuel. Okay, so Manuel's going to read. All right, go for it, Manuel.
Many people enjoy a cup of coffee at some point during the day. Some may drink it black, while others may put cream or some dining substance and sugar in their coffee. You can buy high-end coffee drinks at espresso stands. Either sit down or drive through. Whatever you prefer, you want the coffee to be at the same at the beginning and at the end of your drink. You don't want the components to separate out, but you want your drink to be uniform from top to bottom.
And what do they mean by that, Manuel? Is like, I don't know about you guys, if you drink coffee or maybe you guys are more tea people, but me, when I'm doing my coffee, I like, because I always use my Yeti cup. So, it's a lot longer. It's about 16 ounces. And my Keurig, it fills it up pretty much all the way to the top. So, me, when I drink my coffee, I like to put cream, vanilla creamer, and some sugar. Well, what if I just pour it in there and don't mix it? Is it going to be uniform from top to bottom? Will it taste the same like as the Manuel was reading? Will it taste the same at the top than it will at the bottom if I don't stir it? Think about that. I mean, a lot of us have probably seen mom or dad or grandma and grandpa drink some coffee, add some milk, and stir. Well, what if they didn't stir? What if they let the cream and the sugar sit at the bottom of your container? And what if you just start drinking it? Will it taste the same at the beginning as it will when you get to the bottom?
No.
No, right? How's it going to taste, Regina? Tell me, what do you think?
Different.
It's going to taste different.
We need to mixture.
Okay. Right. That's exactly right. It's going to taste different. It's going to taste really bitter at the top because there's no cream or no sugar. And then when I get to the bottom, it's going to be super, super sweet, right? Because all the sugar and the cream is at the bottom. So what do? We mix it, right? We stir it up. It looks nice and brown. And you can see that the color completely changes. That is because you have dispersed everything that you've put in it, and you've made it so that it's even from the top of the cup all the way to the bottom. Okay? So I want you to think about that when we are talking about this section. Okay? All right. So we have mixtures. Ordinary table salt is known as sodium chloride. So that's two elements, sodium and chlorine. It's considered a substance, a pure substance, because it is uniform and definite in composition. Uniform means all the salt looks the same, right? It all looks white and it all looks crystally. That's what we mean by uniform. All the particles look the same. Definite in composition means that there's one sodium and one chlorine in every single part of that salt. All samples of sodium chloride are chemically identical, meaning the formula is the same. Water is also a pure substance, right? You have to have 2 hydrogens, 1 oxygen, and bam, you got water. Salt will easily dissolve in water, but salt water cannot be classified as a substance because its composition can vary. Okay, and what do we mean by that? You may dissolve a large amount of salt or a large amount into a given amount of water. All right, so the fact that the solid salt went into water and became a liquid version of salt doesn't change the salt. The sodium chlorides are still floating around, but they're just in a different state. They have changed from from a solid state to a liquid state. And how do you know that the salt is still in there? Well, if you taste it, you can actually taste the salt. Okay, it's not going to taste like water. It's going to taste like salty water. Now it's a mixture because the water, H2O, and the salt are not chemically bonded. They're physically just blended or stirred together. A mixture is a physical blend of 2 or more components, each of which will retain its own identity and properties in the mixture. Okay, so water will still boil. The water portion of the solution will still boil at 100 degrees Celsius, and we can get rid of the water and leave the salt behind. It's going to look a little bit different, but the salt will still be at the bottom of our pan. And it'll still taste the same. It may look a little different, but as far as it having sodium and chlorine, yes, it will have both of those. The form of salt has changed when dissolved in water. It still retains properties and compositions. All right, so I want you to show you this video because it's really, really cool.
The world we live in is made of things. Billions and billions of different things like pickles and pianos, and dump trucks and octopi. And even though these things seem totally different, they're all made of the same stuff, just combined in different ways. To give you an idea of how this combining works, let's take something apart. Let's start with this bowl of macaroni salad. If you were to reverse a recipe for macaroni salad, you'll see it's made by mixing together a bunch of ingredients, like macaroni, mayo, vinegar, vegetables, and mustard. This type of combining is called a mixture. When you make a mixture, you're combining 2 or more things together without actually changing the chemical identity of those things. Like mud, for example. The soil and water in mud haven't actually changed. They're still soil and water. You've just created a mixture of soil and water. Mud. It turns out that macaroni salad is actually a mixture of mixtures, because many of the ingredients, like mayo and mustard, are already mixtures themselves, which is nice for us because if we look closely, we'll see the 3 main types of mixtures that exist. The size of the particles in a mixture determines the type of mixture. On one end of the scale is a suspension, like our muddy water example. You get this if you take big chunks of something and mix it with something else, so those chunks are just floating around. Take runny mustard, for example. You'll see a bunch of little particles like mustard seeds, pepper, allspice, and minced shallots all floating around in a liquid, in this case, vinegar and water. This is called a suspension because you've got particles of one thing suspended in another. Now, on the other end of the spectrum is a solution. The particles in this mixture are so small, they are the actual molecules. A solution is sort of like a suspension of molecules, where one type of molecule is blended or dissolved with another. Vinegar is an example of a solution where the molecules of acetic acid are blended with molecules of water. The chemical properties of the molecules haven't changed, they're just evenly mixed together now. Salt water and carbonated soda are both examples of solutions where other molecules are dissolved in water. The last type of mixture is called a colloid, which is somewhere between a suspension and a solution. It's when you take 2 materials that don't dissolve and you make the particles so small that they can't separate. Mayo is what happens when you take oil and water, which don't mix, and you bind them together, usually with the help of another substance called an emulsifier. In the case of mayo, it's lecithin found in eggs. And now you're left with really...
Oh, this is actually a lab that we try and do in school. It's a really cool lab. I hope when we go back, we're able to do this lab. But whatever you do, don't actually try the mayo that we make. I bring another mayo from the store, and we usually do corn in a cup after we're done. But it's a really cool lab. Everybody usually likes it.
Small globs of oil hanging out with really small droplets of water. Whipped cream, hairspray, styrofoam, and jello are all other examples of colloids. So let's get back to macaroni salad. You've got colloids like mayo, suspensions like mustard, and solutions like vinegar. But you've also got celery, shallots, and all other vegetable chunks that are also part of the salad. These aren't mixtures really, but we can break them up. Just like a TV can be broken up into smaller and smaller complex component parts. In the case of vegetables, if you keep breaking things up, you'll eventually end with thousands of complex organic molecules, things like ATP synthase and RNA transcriptase and water. So now, once we've unblended all the solutions, unmixed all the colloids, separated all the suspensions, and taken apart all of our vegetables, we've reached the end of what we can unmix physically. What we're left with is a whole bunch of molecules, and these molecules remain chemically the same, whether they are by themselves or thrown together in a salad. If you want to separate these guys even further, we need to unmix things chemically, which means we need to start breaking some bonds.
I really like that video. It's a really good video. I like especially the fact that it shows you those compounds at the molecular level, because that's literally what they look like, except they're doing a lot of spinning. All right. So let's go into homogeneous mixtures. Get your highlighters ready. Make sure that you highlight the important information that you need. So we have a homogeneous mixture is a mixture in which the composition is uniform throughout. The salt water described above is homogeneous because the dissolved salt is evenly distributed throughout the entire saltwater sample. So let's go back to our coffee. Remember how we were talking about the coffee and that creamer and sugar being spread out evenly, okay? That's what we mean by the composition is uniform. It doesn't matter if I take a sample from the top, the what's at the top of our coffee or what's at the bottom, it'll still should have the same amount of cream and sugar, whether I take some at the beginning or whether I take some at the end. Okay, the ratio between the coffee, the cream, and the sugar should be the same top, middle, and bottom of my cup. And usually, that's how come it looks all one color, because it's evenly distributed. Often it is easy to confuse a homogeneous mixture with a pure substance because both of them are uniform. Both of them are spread out evenly. The difference is the composition of a substance is always the same. The amount of salt in the salt water can vary from one sample to another. So if we all go into the lab and I say, okay, I need you to get into groups. I need Luis and Regina. You guys are gonna go to the table in the back and go make some salt water. And I don't tell them how much salt. I don't tell them how much water to put. And then I tell Juan Soto and Abram, and they're going to go to the other side of the class, and I tell them, hey, go make me some salt water. They're going to use different amounts, okay? They're going to use different amounts of salt or water, and it's going to make their samples different from one group to another. That is the difference here. When it comes to pure substances, if I say, hey, I need you to mix sodium and chlorine, Luis and Regina, and then Juan Soto and Abram, I need you to make salt. Here's your salt. Here's your sodium. Here's your chlorine. Now, when we're making sodium chloride, there's a specific way that you do it so that both groups will come out with the same compound. Now, can there mistakes be made? Yes, but most of the time, if you follow directions, you should come out with the same substance. That is the difference here, okay? That's the difference between a mixture and a pure substance. Pure substances, it doesn't matter who's doing it, it's going to come out the same. Mixtures, it's a free for all. You do your own thing. All I want is my product. Okay. All solutions would be considered homogeneous because the dissolved material is present in the same amount throughout the solution, right? If I go to California, if I go to Florida, and if I go to the island and I get water from the ocean, the water is gonna, the concentration will be the same. The amount of salt inside that water is the same. It doesn't matter if I get it from Cancun. It doesn't matter if I get it from California. It doesn't matter if I go to Maine and get some. It doesn't matter if I get it from Florida. The same amount of salt should be in all of those samples, technically. Okay? That's technically what should be true. One characteristic of mixtures is that they can be separated into their components. So mixtures, they can be restored. Okay, they can come back. Since each part of the mixture has not reacted, it's not chemically bonded, the identity of each of the materials is not changing. Okay, and I like this video because I can tell you a lot of examples of what I mean by that.
Let's take a look at another important question. The question is, what is a mixture? To work on the answer to this question, we recognize that there are actually two different types of mixtures. We're going to take a look at first chocolate milk here. Chocolate milk is an example of a homogeneous mixture. Now, homogeneous is actually going to mean the same throughout. And that means that basically if you were to allow the chocolate milk to evaporate, you would find that there would just be chocolate and sugars at the bottom of the glass. But basically, when you just drink chocolate milk, it feels like and tastes like the flavor is evenly distributed all the way throughout the chocolate milk. And that's because in a homogeneous mixture, all the particles are evenly distributed. And if we go ahead and we take a look down here at lemonade, we see lemonade is also an evenly distributed mixture, so it's also going to be homogeneous. And if we come down here to salt water, you find is also a homogeneous mixture primarily. If you just look at just specifically the salts and the water in it, not some of the other particles that may be floating around, which would make it more or less heterogeneous. And now let's go back over to heterogeneous. For things that are heterogeneous, such as trail mix, you can see trail mix is actually pretty cool. There are all kinds of goodies in there. But let's say, for example, all you were interested in having were the green M&Ms. Well, if you just wanted the green M&Ms, you could take those out, which means for a mixture, you can separate it by physical means. It means you can take it apart. Let's go ahead and take a look down here at a salad. Let's say you didn't want to have cucumbers in it. Well, you could take just the cucumbers out. You could take it apart by physical means. And that's important to know when you're talking about the difference between heterogeneous and homogeneous. Number one, homogeneous means everything's evenly distributed throughout. Heterogeneous means, no, things are not evenly distributed throughout. Yet for both, you can take them apart by physical means. And let's go ahead and take a look down here at some granite. The particles of rock that make up granite, well, they are not evenly distributed. Not like they are in lemonade, not like they are in chocolate milk, and not like they are in salt water. The particles that make up a piece of granite are not evenly distributed. So whenever something is evenly distributed throughout, it's homogeneous. When the particles that make up the matter are not evenly distributed throughout, it's heterogeneous. But both for homogeneous and for heterogeneous, you can both separate them by physical means, and that makes them be very much in common.
All right. Stop. Okay. So here are some really good examples of homogeneous mixtures. You can notice that the chocolate is evenly dispersed. Okay. When you first make this chocolate, you're going to pour the milk and then you're going to pour the chocolate afterwards, and you'll see that chocolate just sit at the bottom. It doesn't become uniformed until you stir it and you make sure that that chocolate is evenly distributed. So the amount of chocolate here at the top should match the amount of chocolate at the bottom. Okay. The same thing for the lemonade. Even though you see it kind of light on top, that's mostly because of all the ice that's sitting right here. This color is pretty much the same all the way up and down. It's just that the ice kind of makes it look like it's light on top. But either way, the lemonade will taste the same at the top than at the bottom. Same thing here. It doesn't matter if I take a sample of water in Florida or here or in California, the amount of salt that's in here should be the same. Now, let's talk about heterogeneous. This is what we mean by uneven. Okay? If you look here, there's a lot of nuts, right? There's a bunch of nuts. You can say that probably like 60% of this trail mix is different types of nuts. You can say that maybe 10% is chocolate and the other 20% or whatever is left is raisins. That's what we mean by the amount is not the same. I don't know if you've ever eaten trail mix, but my husband does, and he hates it because he knows that I don't like the raisins. So when I grab that trail mix, I always throw back the raisins in, and he's always pissed. He's always upset at me because at the end, when he gets to the bottom of the bag, it's all raisins. Okay. And the reason is because I ate all the chocolate and I ate all the nuts, right? The same thing here in this salad. The amount of lettuce you can tell is about 70% of this salad, maybe even 80%. Maybe 10% are the tomatoes, another 10% is cucumber, and maybe another 10% is carrots. But you can notice that there is an uneven amount. I don't have the same amount of salad. I don't have the same amount of to tomato, to cucumber, to um to carrots. If it was, then you can maybe call it a homogeneous mixture, but in this case, no, because everything is uneven. The same thing here with the rock. You can tell that there's a lot of white in the middle right here. There's some pink over here or brown at the bottom. And then you have some dark spots. You can tell that whatever makes up the minerals that make up this rock are totally in different proportions. You can probably have 25% of calite. You can have some diorite, or maybe even some calcium. You can even have rocks in here. All right, and you can easily tell that there's more minerals of one particular mineral than the other. Okay, everybody got that? So let's talk about the air. Take a deep breath. All right, and let's see what is in the air after you've taken that breath. Alrighty, and I want to make this quick, okay? Because I know we spend a lot of time on grades. So if you look at what's in the air, it's a mixture because you're going to see the different types of molecules. If I click on this one, you could tell. Let me just lower this. You have nitrogen making 78% of all the air that's around you right now. Let's look at these blue ones. No, that is methane is, I think. Hold on. There we go. Oxygen. Look at oxygen right now in your room is about 21%. So right now, most of the oxygen and gases around you is O2 and N2. Everything else you'll notice, let's look at hydrogen. Hydrogen is a real small number. Water, it's also a real small number. Carbon dioxide, really small. Methane, it's a tiny amount. And let's look at the atoms that are in here. Helium, small number. Neon, small number. Argon, it's about maybe 0.1%. Krypton, small number. Xenon, very, very small number. Okay, so just right now in your room, you are breathing probably 21% of oxygen and 78% nitrogen. And you always want nitrogen rich because nitrogen helps plants grow. They usually that's their food of preference, other than the sun, of course. All right, so in summary, a homogeneous mixture is a mixture in which the composition is uniform throughout, meaning the amounts of whatever is mixed is the same, whether it's top, bottom, or or the middle. All solutions can be considered homogeneous. And then you have your review questions. What is a mixture? What is a homogeneous mixture? Are all solutions homogeneous mixtures? And can homogeneous mixtures be separated into parts? All right, so this is your assignment. Get it done. You have about 9 minutes. You can still get at least half of it done. All right, don't just give up right now, guys.